Hey guys, welcome back to the RCA CTC5 restoration project. So when we last left off, got the set working fairly well, and I want to clarify a few things because I don't think I explained it that well. The high voltage regulation issue, blooming issue, has basically resolved itself. Why? How? Not entirely sure, but I did get one interesting comment on Video Karma from Tom, who said that those shunt regulators can get kind of stuck on, and it might be loading down, or might have been loading down, the high voltage supply. See, the way that high voltage regulation works is it's not so much like a Zener diode. That's what I thought originally. It's that it's a load balancer. So say your high voltage supply is designed to put out 1 milliamp. If the picture tube with its current brightness for the given scene is 0.5 milliamp, the shunt regulator should have 0.5 milliamp. If the picture gets brighter and it needs more current, the shunt regulator should back off and let the picture tube have more. If the scene gets really dark on the picture tube, the shunt regulator should start conducting more, so it's a constant load of 1 milliamp. And everything's designed right, if everything is designed and set up right, such that you should have, I think it's 22,500 volts with a 1 milliamp load, everybody's happy. But if something's out of whack, like the shunt regulator's not behaving itself, it could be loading things down and it would starve the picture tube. So that's a possibility. Now it's a little bit low, but the regulation is pretty good. Now, I don't expect it to be 1% across the board from the brightness being lowest to highest. It's going to vary a bit, but it's working way better than it used to. So anyways, what I really want to get into in this video is the convergence. So several of you have said, hey, why don't you just go through the convergence procedure and see how good you can make it? Yeah, well, that's what I want to get into in this. I don't think you realize what you're asking. One, it's not trivial by any means. Two, I don't really have all the equipment I would need. Three, I don't know that it's physically possible given the condition of the yoke. And four, I don't really have the room where it's currently at because you don't do everything from the front. You need to get around to the back and poke around and manipulate stuff. And it's a little bit tight quarters in the room it's currently in. The final thing is, I don't know that I want to. By that I mean spend the time. I have something like 100 plus TVs to restore, including 3 more color sets. So yes, I would like it to be as good as I can possibly make it in a reasonable amount of time. I got a lot of other stuff I need to get to, and I have very limited time to work on these things these days. So anyways, let's get through it. Now here's another thing. This is the RCA manual for this set. Some of the stuff like this is installation instructions, like you would do this if you were installing this right out of the box in a customer's home. I'm not. So I don't know that I need to do all of these steps. Or if you replace the picture tube, you need to do some of this stuff. I didn't. So anyways, let's just briefly look at all the various steps. So installation instructions. So they say it should operate normally, whether you're looking at black and white or color, just as it is. However, if you look at a black and white image and you notice some color creeping in, you may need to degauss it. So these color picture tubes, they have a screen or an aperture grill made out of iron alloy. They can get magnetized. But also this has a metal cone that's iron, that's ferrous around the entire CRT. So if you were to walk by the set with, say, a radio that had a permanent magnet in it and you got too close to it, you could permanently magnetize a portion of the picture tube, and then you'd get a color splotch in that area. So they say degauss it. Cool. I do have a degaussing wand coil, but it's not that simple, because there are neutralizing magnets. There are 6 magnets spaced around the screen, permanent magnets, and if you were to wave a demagnetizing coil over those, you'd screw them up. So you need to retract them into the pockets. which is not trivial to do, and I haven't actually figured out quite how to do that. I think that might be a little bit stuck on mine from sitting in the same position for decades. So I haven't done that. It looks like in the upper right-hand corner of mine, there might be a slight magnetization issue, but I'm not entirely sure because I've had another TV sitting on top of it that does have a permanent magnet speaker in it. And I repositioned that set, and I think it eliminated that issue. You don't always see it. It depends on what color is currently on the screen. So anyways, let's get into this. So now more physical stuff. Remove the rear panel of the receiver and check the position of the convergence coil and blue lateral magnet assemblies. I did that. They're talking about this kind of stuff. Now this is where I got into the condition. The yoke plastic enclosure on mine is miserable. It's in the mid-50s. The plastic they used on a lot of yokes did not hold up well over time, to put it mildly. Mine is intact. If I try to move it, it might very well fall apart, so I don't want to move it. I think I need to slightly, if I can, rotate the yoke just slightly. It's not completely level, but it's close enough that I'm okay with it. But I did move the blue lateral magnet. So this is the stuff they're talking about. So like that's the blue lateral magnet. You put it over that whole piece. I did that. This thing is pretty well frozen on mine, and I don't want to force it. So that's what I mean about I'm skipping some of these steps because I don't want to do more harm than the current situation. Okay, that's the easy stuff. Now let's really get into it. Now again, this whole section here is assuming that your set has already been set up and it's working pretty well, but you've got some fringing issues. So they instruct you to hook up a dot generator, which is a big chunk on here because dot generators back then were not like the modern pattern generator I'm using now. For some types, they actually tell you to tune to an over-the-air signal to get horizontal and vertical sync pulses to lock the image, but inject a dot pattern into it. So you're getting the sync pulses from over the air, but the video comes from your generator. Because, yeah, some of these things were pretty primitive back then. But assuming you've got a bunch of dots on the screen, so each dot should be just a pinpoint of white, ideally. So they go through this, and they go into the DC adjustments, and that's what I did do. That's not too horrible to go through. It's also annoying in this, they talk about stuff here, but you have to flip over to another section to actually see where the controls are. So these are the static convergence adjustments. I talked about these a couple times in earlier videos. And they're scattered around. So you got red DC and green DC concentric in the bottom left, blue DC lateral, blue DC. This is one when I rotated it when I had a grid up on the screen where just things got dramatically separated or came back together. So that's static convergence, or DC convergence. What that does is it puts a DC current bias on some of the components. What you really focus on with that kind of stuff is in the middle of the screen that things are good. When you look at the edges and some of those lines start separating, when you're looking at a crosshatch or a few dots, they start separating. That's more the dynamic stuff you get to later. This does not use the later type of convergence controls where you've got a little panel and there's usually some selenium rectifiers and a bunch of trimmer pots. This is a different system. I'll try to show it on a schematic. So this is the heart of the convergence system. It's a transformer. We've got variable potentiometers over here. That's your DC stuff, your static stuff. We've got variable inductors over here. That's your dynamic stuff. And it all goes into this transformer. So the DC will put some currents into this, which offsets things. And then the coils work more well on AC dynamic signals. So for the potentiometers, we have things like red DC, green DC, blue DC. and red vertical tilt, green vertical tilt, and blue vertical tilt. And the blue DC lateral. The variable inductors are the horizontal tilts and vertical amplitude, or sorry, those are more potentiometers. Which leads to some confusing things in the instructions, because we'll see at one point where they say turn everything to minimum. Okay, well, potentiometer, you just turn all the way down, counterclockwise, right? What's the minimum on a coil that you can't even see? So yeah, we could start going counterclockwise, but it turns, and you don't want to get too far. You break the thing, or the slug will fall out. So what is minimum on a variable inductor? Don't know. I just did my best. And then there's also screen adjustments up here, which sets basically the brightness levels in the red, green, and blue guns. So that's what all those controls are for the front. Screen, the DC, and the tilt stuff, which would be dynamic convergence, basically, and the amplitude. So back to this, I talk about the DC convergence. The above adjustments should be all that are required in those few cases where conditions mentioned exist at the time of setup of the receiver, when it's brand new. However, these adjustments do not correct the condition refer to complete setup procedure. So, since mine's had a replacement picture tube, obviously I overhauled the entire chassis and I cleaned the controls and rotated them. Yeah, I should go through and do the complete setup. So let's take a look at that. Just further down, they talk, before we get to that, they talk about more adjustments like height linearity, your typical TV setup stuff. And then there's a whole section on if you replace the picture tube, which, like I say, was done, and I am just going to have to assume that when they replaced the picture tube, they did a decent job. All right, here's the complete setup procedure. Are you ready? So one of the headaches of doing this, it's not just you sit in front of the set and adjust those controls. At some point, you need to go into it and pull a fuse out, or hook up a voltmeter and measure the screen voltages on the CRT socket. It's not just twiddling some controls. I wish it was. It's not. So, preliminary stuff. They talk about AGC and horizontal oscillator a little bit. I'm going to skip over that. So again, with the dot generator, and it's funny, after going through the complicated part, they say, no, dot generators which provide an RF output may connect to the antenna terminals, which is what I did, so I don't have to do any of this section here. So now we're using our dot pattern. And this was a little diagram showing you got your dot here in red, green, and blue. And they talk about various controls for red, green, and blue. If you adjust the green control, it moves things this way. Red this way, and blue up and down. This is what I meant about preset the red, green, and blue horizontal and vertical amplitude controls to minimum, fully counterclockwise. Well, I think, as memory serves, some of those are potentiometers, but some of those are coils, so I wasn't quite sure how to do that. Then preset the red, green, and blue vertical tilt controls to mid-range. So I muddled my way through that. And then they say to adjust the DC controls and the lateral control to get the dots, well, to not be separate red, green, and blue, but just one white dot. I did an okay job with that, I think. The color purity stuff, that's where things start to get a little more complicated. And this is what I mentioned about doing the demagnetizing again, which I did not do. And set the red tabs and the purity magnet together, refer to figure 8. So what are the purity magnets? So again, you got to go back into the set. So there's a whole bunch of stuff on this now. We got a blue lateral magnet assembly, your purity adjustment tabs. They look like centering controls on a black and white set where you have two rings and tabs sticking out, and you can rotate those tabs independently. And then behind that, convergence coil and pole piece assembly, purity magnet assembly. Then you get to the deflection yoke. So that's what they're talking about with those tabs there. Retract the 6 field neutralizing magnets into their housing. That's what I was talking about with those permanent magnets you do not want to mess up. To do that, you have to take the whole front of the set off, which I've already done. And I say loosen the wing nuts at each side of the yoke and slide the yoke back to the rear as far as possible. No, I'm not doing that. I'm not loosening up the yoke and trying to move it around on the neck. I'm not going to risk it falling apart on me. Turn the blue and green screen controls fully counterclockwise. I did do that. And those are in the upper right. Blue screen, green screen, and red screen up here. And you're supposed to move the yoke forward and backward and adjust for best overall red screen uniformity. Sorry, I skipped a step there. So you turn the red and the green down so you just have red on the screen. And you're supposed to move the yoke around so you get good uniform redness across the entire screen. Didn't do that, I don't want to move the yoke. And then you rotate those purity magnets, those concentric rings I mentioned. That's what you adjust those along with the yoke to get that uniform red. And you're supposed to tune in and receive a black and white picture and adjust the neutralizing magnets for best white uniformity in the areas of the individual magnets. And here's those neutralizing magnets they're talking about. I didn't do that. And we're just getting started. Kinescope temperature, screen, and background adjustment. Set the screen controls maximum counterclockwise, and the green and blue background controls 30% for maximum counterclockwise. Turn the contrast control to the center of its mechanical range. Measure the bias and the red gun between the grid and the cathode using the voltomist. It's a RCA branded voltmeter. And adjust the brightness control for a reading of minus 70 volts on the meter. Leave the brightness control at the setting and adjust the 3 screen controls for a gray picture color temperature of 8200 Kelvin at a very low light level. I didn't do that. After setting the screen controls, do not change the setting of the red screen control to the balance of this procedure. And then we do green and blue green and magenta and yellow and red. And you do various steps of adjusting those background controls, background being screen, I do believe, to get certain pigments. So what did I do? I brought up the industry standard color bars and tweaked these to get the colors to be right. So I know this bar is supposed to be red, this one's supposed to be cyan, this one's supposed to be white and magenta and so on. I just eyeballed it like that. I didn't go through and do all this. I'm not saying I won't, I'm just saying I didn't. Because I didn't want to get out a voltmeter and get in there and measure. I'm not even sure if I can with the socket connected to the CRT. And anyways. We have a whole lot more to go. So assuming we got through all the color temperature adjustments, then we get more static convergence adjustments. Here's what they're talking about. At the center you've got a dot, and as you get further away from it, things might start diverging. And go through and do these steps to get it looking best in the middle. And then we get to the dynamic convergence. And here's what we talked. I illustrated that earlier when I had a crosshatch up. But you can get the lines to be right in the middle, where you have a nice white line, but as you get towards the edges, you start seeing red, green, blue lines separating. That's what the vertical dynamic convergence goes. So the red, green, and blue vertical tilt and red, green, and blue vertical amplitude get adjusted in these steps to correct that, to go from the lines diverging to the lines being on top of each other. Then you need to do the same thing for the horizontal, which I also illustrated earlier, where you want those 3 lines horizontally to be right across the screen, dead on top of each other, but typically they will dip and bow and wave a little bit. So you've got red horizontal tilt, well, red, green, and blue horizontal tilt, and red, green, and blue horizontal amplitude. So 6 controls to adjust there. Now to do that, I just looked at it and adjusted them. But you're really supposed to shunt the red grid of the kinescope to the chassis rear apron through a 10K resistor to ground. And alternately adjust the green horizontal amplitude and tilt controls to produce a green bar parallel to the blue bar over the entire length of the center of the screen. And then you remove the shunt and you shunt the green. So in other words, you don't do all 3 at the same time. You shunt one of the other guns while you get 2 of them going parallel to each other. And they go into cleaning procedures. So that's basically it. There are a few other things I'll try to dig up about, like when I mentioned popping that fuse out. Oh yeah, it's coming back to me now. So that was adjusting the convergence, but there's also a whole bunch of other stuff if you really want to get in deep, which is doing an alignment, which consists of video and bandpass alignment, AGC alignment, color AFC alignment, and color threshold control adjustment, demodulation phase adjustment. Basically, all this stuff, all the coils on that, which I also did not do because it's working fairly well as it is, so I didn't want to muck with it. So, without diving more deeply into the alignment stuff, that's why I didn't go through and go A to Z and do every step on this. Is some I'm wary of doing more harm than good. Some didn't quite make sense to me, or the set didn't respond quite like how they described. I do want to get the high voltage up a bit. So we're sitting now at around 19.5, 19 3/4. Oh, interesting. Interesting. That's what they show on here. The SAM shows 22.5, but the RCA shows 19.5, which is where we're at, basically. So I don't know that I want to mess with it too much, if that's actually. I go with RCA more than SAMs, because SAMs would reverse engineer stuff. I mean, the RCA are the ones who designed and created this thing in the first place. I would like to make the modification, though, at some point, to make the operating point of the 6BK4 shunt regulator adjustable. Right now, it's fixed, and every other CTC chassis was adjustable to save some pennies. They took out the control on this set, but they put it back in with the next model and every subsequent model that came out. But something else, there's also an efficiency coil. They call it the horizontal linearity coil in this. It's between the damper and the horizontal sweep output tube. It's hard to get at, but I did with the set turned off. The slug seems to be frozen going in from the top. On the bottom of the cabinet, there is an open area. It's got a screen over it. If I took the screen off, I might be able to get at that coming in from the bottom. But what I'm thinking is when I take the chassis out to make a variable high voltage adjustment, I'll check out that core and see if I can free it up. I think it might be this on the schematic. This is horizontal tuning here. You're supposed to adjust it for minimum current, minimum cathode current through the horizontal sweep, which is what you want to do anyways. They say that should give you the best horizontal linearity, but also you want to have the least amount of current going through this circuit as possible, because you don't want to stress out that flyback. But you also want to get sufficient high voltage that you can get a good sharp bright picture. So That I will get to when I get to. Now, here's the reality. As the set sits right now, I can kick back and watch it. It's good enough for me. I hope that brief explanation of the convergence procedure made some sense and you understand why I did what I did. That's going to be it for now. Thanks for watching.
Nothing like sheep. Hippity, tippity, pow! I've got to start planning Spooky's future. Now first,